Okay, this is the review for the wave activity you did today. You can see in red that I have the answers. So how did you organize the experiment? What I'm looking for is the description of what you did in the experiment. When you do the description, make sure to talk about what you measured. So I said we had one person do the wave and timed how long it took them. Then we added one more and timed it again. We continued to add people and record the time. So I talked about recording the number of people and recording the amount of time it took them to do the wave. For those of you that weren't here today, the wave is just that, you're bent down, you lift your hands up, and then you sit down again. So sometimes we had groups say, wait, you messed it up, we have to redo it. And I said, how did you know when you had to redo it with the same number of people? Like, what mistake did you see? And I talked about sometimes we had more people, but it took less time than it did before. For example, if it took 3 people 2.5 seconds, then it should take 4 people longer than that. I have data from one of the groups here, and you can see if I focus you here, with 2 people, it took 0.78 seconds, and with 3 people, it took 0.66 seconds. So that group may have looked at it and said, wait, with more people, it should take more time. And that's an important relationship you would have already seen. I asked, did all the points fall directly on the line? Why or why not? And again, if I use Desmos, you see my green data points and my orange line of best fit. Those points did not fall directly on the line because you can see the rate of change from point to point is different. When we've done them before, the slope or the rate of change was constant. It was always the same. And between these points, that wasn't the case because we'd have somebody come in and change our rate. We weren't always the same. What effect could one person have on the time? I said each person went at their own rate, and some of the groups had each person going almost the same rate, and then we had some of the groups where one person went really slow and everybody went a little faster. And sometimes they went really fast. So they could have an effect on the overall time by making it faster or slower. The independent variable and the dependent variable, the independent is what you're controlling. You guys were controlling the number of people. You kept adding people. The dependent was the time. The time depended on the number of people. So then we created a scatter plot. We used Desmos because we had the Chromebooks in class, but you could use Excel as well. When again I show this in Desmos, you should see that this is a positive correlation. Okay, it's moving up. I would say this is a strong positive correlation because all of these points are very close to the line. What did you see in the table to show you that? And what you should see in the table is as the numbers increase here, the time also increases. So a positive relationship will have one increasing and the other decreasing at the same time. What did you see in the graph? The line of best fit had a positive slope and moved upward from left to right. So the graph is showing you a positive relationship because it's a positive slope and the points are close to the line. So use the calculator to find the best line of best fit. In Desmos, we did that. That's here. And it says right here, the slope was 0.154 and the y-intercept was 0.409. So 0.154. So y equals 0.154. X, because that's where the slope goes, plus our y-intercept was 0.409. Okay, and I'll see if I can bold that for you. So there's my equation. I got that from the calculator. The y-intercept here, let me see if I can change the color to make this a little easier, is 0,0.409. I'm getting that because I know slope intercept, and that's where that is. So what does this mean? Well, X stood for people. So this means 0 people took 0.409 seconds. Okay? And that doesn't make sense. And you would say something like this does not make sense. 0 people, oops, sorry, typo, should take 0 seconds. What is the slope? So again, you are looking at the equation that the calculator gave you. I have 0.154, and that is like over 1. We talked about this at the computer lab. Slope is found is the change of y over the change in x. In this problem, y was time. So this is saying time over people. So this is saying that time will increase because it was positive, 0.154 seconds for each person. So you can see here, this might help some of you to start, and then over here is where you will make sure to say increase or decrease, is it positive or negative, and put the units with it. This question has been tricky for a lot of the groups as I heard them discussing it. Does every point on the line of best fit make sense, why or why not? So I'm going to go to the graph on Desmos. And here I'm doing, these are different points on the line of best fit. So for example, if I take this point right here, it stands for 3.38 people and 0.931 seconds. Now, the question is, does this point make sense? And the answer to that would be no. Now, the 0.931 seconds is fine. The 3.38 people is not okay. You cannot have a fraction of a person. So in this answer of does every point on the line of best fit make sense? No, because you cannot have a fraction of a person. Okay, now sometimes you're going to measure things where you can have fractions of a centimeter and fractions of time. But in this particular experiment, no, because anytime it has the x value as a fraction, it's not going to make sense for ours. Now, future prediction equations. Our class has 29 students. Use your equation to determine how long it would have to take the entire class to do the waves. So 29 is people. Which was people? X or Y? X. So we're going to type in 0.154. I'm going to replace X with 29 plus, let me go back to look at what it was, 0.409. Okay, if I plug that in, let's do that on the calculator real fast, 0.154. I get 4.875 seconds. Okay, for this one, I would not round the answer. I'm looking for rounding to the whole number, not rounding like to the 100th. So I would not round the answer because it is possible to have 0.875 of a second. So that's what I'm looking for with this, is are you rounding it to the whole number, and if you are, when? So you can see that here. This is the answer I would give, 4.875 seconds. Now in the next one, how many students would we need to have in order to have a wave that lasted at least 15 seconds? So I'm going to take my equation. Now 15 seconds, 15 is the y variable. So I'm going to plug in 15 for the y, and this time I leave the x. I'm going to solve that equation. I'm going to have 15 minus 0.409. That gives me 14.591 equals 0.154x. And I get 94.75 people. Now, in this one, I would round because I cannot have 0.75 of a person. Now, the question here is, a lot of you are going to say round up because you're using your rounding rules. But if you look at this, at the time of 15 seconds, did that 95th person actually get up? No. So I would round down to 94 because the 95th person did not finish the wave at 15 seconds. So be careful. I think a lot of you are going to have to change your answer for that one. Now, I didn't get equations from the other two groups. For these questions, did all the groups get the same numbers? Why? I'm looking for a no because the people went at different rates. When you compare your slopes with another group, I would hope that you would find one might be faster than another because their slope was a bigger number. So for the group that I used, their slope was 0.154. If I went up against a group that was 0.97, obviously we went a lot slower. I can see I did miss one question with the r squared value over here. Let me go back to that. For the r value, that's going to show you how accurate your model is. If it is 1, then it would be perfect, and every point would fall on the line. Now, for the group I used, when I go to their R value here, it's 0.917, which is pretty good. I saw some other groups that had 0.965. So the closer you are to 1 shows it's pretty accurate. So if you're, I'd say above 95, you're a pretty accurate model. So again, you are going to have these questions for a different experiment. This video and the answers here should help you rewind and pause as you need. Okay.